take a look at this page before we begin naming compounds, you have to understand a couple of different ideas behind this. And the couple of different ideas that we have to look at: how do ions form? And our last assignment, in which you were asked to name or to write out the process for how cations and anions form, hopefully helps us. I'll make sure that we've got that covered a little bit. Once you have an understanding of how they form, why does an atom turn into a positive ion, or how does it turn into a negative ion, then we're going to take a look at how do you utilize the periodic table. If you look at the elements that are on the periodic table, what clues, based on the position where we find them on the periodic table, help us to tell whether something's going to be positively charged or negatively charged, and then to what extent is it going to be positively or negatively charged? Okay, let's first take a look at, if I have the sodium atom. Let me change my pen color here. Change it to white. The sodium atom has 11 protons. That's its atomic number. So I have 11 things that are positively charged. We say that an atom is neutrally charged. It has no charge at all. So in essence, there would be a little zero up here. We don't write it because it's just understood that if I see this with nothing up there, then I'm assuming it's neutral. If it has 11 things that are positive, our goal is to get to a charge of 0, where there is no extra positives or no extra negatives. So what I'm going to look at here is the fact that it has 11 electrons also. So if I take 11 things that are positive and I add them to 11 things that are negative, I get a charge of 0. So we say it's neutral. Well, for reasons that we're not going to quite get into yet, we will, and I'd like to cover that in class on a face-to-face basis. Metals tend to lose electrons. They give them away. Where do they go to? Well, you're going to find that they end up going to nonmetals eventually. So metals tend to lose electrons. Nonmetals will tend to gain electrons. If I lose something that's negative, that means metals tend to form a positive charge. If I gain something that's negative, that means I become more negatively charged. In the case of sodium, if I lose an electron, so I've got a neutral sodium atom, and if it breaks down and it loses an electron, that means that this species now it still has 11 protons. It has to have 11 protons because it's sodium. That's its atomic number. That's the indicator for what substance it is. And so it has to have 11 protons. Well, here's the electron here. If I've got one electron sitting out here, that means I only have 10 electrons left by law of conservation of matter. If this has 11 protons, it can't destroy or create matter, and it had 11 electrons. 10 of the electrons are now in this one, and I've got one electron out here. What that means is this sodium becomes a 1 plus charge. It has one more proton, then it does electrons, so we say that it's a 1 plus charge. In the case of magnesium, Mg, it has 12 protons when it's an atom. It has 12 electrons if it's neutral, if there's no charge. When it loses electrons, it loses 2 electrons. Therefore, its charge becomes magnesium 2 plus. Still got its 12 protons because it's magnesium. But now instead of having these 2 electrons in it, they left. And I have 10 electrons remaining. Okay. Well, what that means then is, if I'm gaining electrons, for example, let's take chlorine. If you look on the periodic table, chlorine has 17 protons, 17 electrons. That's a neutral atom, no charge. I'm going to put the 0 up here for now. Eventually we won't do that. What happens with this, though, is it's going to turn in, when it forms an ion, remember it's a nonmetal. Nonmetals tend to gain electrons, so they become negative. It's going to turn into Cl1 minus. That means I've got 17 protons, because it's still chlorine, so I got to keep the protons the same. But I picked up an extra electron. That means the 1 electron I've got to add has got to come from somewhere. It's going in there. The 1 electron extra plus the 17 electrons from the neutral atom give me 18 electrons. And Cl minus. Anytime I have a single element that has a negative charge, we talk about a monatomic anion or anions. You're going to find they're going to end in whatever element it is, and then they're going to end in I, D, E. In other words, we went from chlorine, that's the neutral atom, to chloride. That's the ion of chlorine. If I have oxygen, which is 2 minus, that would be called oxide. And there's a reason why chlorine is a 1 minus and the oxygen's a 2 minus. It has to do with the way the electrons are arranged in the atom, whether it's going to gain or lose, what it needs to be quote-unquote happy. And we'll look at some of that in a minute as to how you look at the periodic table. Okay. If it's a monatomic cation, like we showed before with the sodium, so the positive charged ones, we don't change their names. For example, sodium plus is just the sodium ion. Aluminum 3 plus, and this plus up here means 1 plus. Aluminum is just the aluminum ion.